In this video, we're going to talk about limiting and excess reactants. So to help explain this concept, let's look at a recipe here for a cheese sandwich. This is obviously a very boring cheese sandwich because it's just bread and cheese, but this is a good analogy to explain how limiting and excess reactants work. So if you have 8 pieces of bread, 3 pieces of cheese, theoretically, how many sandwiches could you make? Well, we've got, let's see, 8 pieces of bread. And let's see, I know that I need 2 pieces of bread to make 1 sandwich. So let's see here. If I were to use a little bit of stoichiometry, I would figure out that I can make 4 sandwiches using the 8 pieces of bread that we have. And then it says I have 3 pieces of cheese. Okay, so let's see. I only need 1 slice of cheese to make each sandwich. So the most I can make are 3 sandwiches. So theoretically, how many sandwiches could I make? Well, I can make 4 with the bread, and I could make 3 with the cheese. So the most sandwiches I could make would be 3 because I'm limited by the slices of cheese. And in terms of the bread, I'd have leftover, or we use the term excess bread in this case. Because we can make more sandwiches, but we don't have enough cheese. So to answer the second part of this question, the ingredient that limits would be the cheese. And the ingredient that would be left over would be the bread. 2 slices to be exact. Perhaps you could have a empty sandwich with no cheese. I'm sure you could find some good use for those 2 pieces of bread made of peanut butter and jelly. Peanut butter and jellies are good. All right, so let's dive into some terminology here. So we've kind of already talked about these. The theoretical yield is the smallest yield of a product. So in our sandwich example, we can only make 3 sandwiches with the number of cheese that we had, and we could only make, but we could make 4 sandwiches for using the bread that we had. So the theoretical yield is the smallest yield. So we could only make 3 sandwiches. The limiting reactant is the reactant that runs out first. So that was the cheese in our example. The excess reactant is the reactant that's left over after the limiting reactant runs out. So we had excess bread in our example. So you know that I was going to kind of come back to chemistry at some point here. Well, here we go. Given the reaction, so we have 2 sodiums plus Cl2, and that yields a product of 2 sodium chlorides. So theoretically, how many grams of NaCl, sodium chloride, can be produced if 8.25 grams of chlorine and 4.83 grams of sodium are used? So we're going to do the exact same thing that we did with our bread example using our chemical reaction here. So we always start with what we're given. So we're going to have to do this 2 times. We're going to have to do it first for chlorine, and then we're going to have to do it again for sodium. So let's start with chlorine. So we have 8.25 grams of Cl2, and the molar mass of Cl2 is 70.9 grams, and that's for every 1 mole of Cl2. And we're looking at our product here. So our ratio is going to be, remember, there's an imaginary 1 here. It's going to be a 1-to-2 ratio. So for every 1 mole of Cl2, we produce 2 moles of NaCl. And now finally, let's look at what canceled so far. So we've canceled out our grams of Cl2, our moles of Cl2. So now we're in moles of NaCl. So now we need to convert it back into grams using its molar mass. So for every 1 mole of NaCl, we have a molar mass of 58.44 grams. So our answer here will be, let's see, 13.6002. So we had 3 sig figs in our original number. So we want to make sure we have 3 in our final answer. So we'll have 13.6 grams. So that's how many we can produce using the 8.25 grams of Cl2. Now we're going to do the exact same thing using the 4.83 grams of sodium. All right, so for sodium, we first need to convert that to moles. Sodium has a molar mass of 22.99 for every 1 mole. And the ratio of sodium to NaCl is 2-to-2. So for every 2 moles of sodium, I have 2 moles of sodium chloride. So my grams of sodium will cancel, my moles of sodium will cancel. And just like before, we need to convert this to grams. So for every 1 mole of NaCl, we have a molar mass of 58.44 grams of NaCl. So I get 12.277. We had 3 sig figs, so let's take a look here. So my final answer will be 12.3 grams. All right, so we can produce 13.6 grams using our chlorine, but we can only produce 12.3 grams of our product using the amount of sodium that we have. So the answer is going to be our smallest number, and that's going to be 12.3. That is our theoretical yield. Okay, so now it says determine the limiting reactant. We kind of already did this. So the limiting reactant is going to be sodium. The limiting reactant remember, makes less product. So for Na, we only made 12.3 grams of our product. The excess reactant would be Cl2. That's our leftover. All right, let's do another example. It says, given the reaction, determine theoretical yield of Na2SO4 when 4.3 grams of NaOH reacts with 6.2 grams of H2SO4. All right, so again, we have 2 separate calculations to perform. So let's start with the NaOH. So we have 4.3 grams of NaOH. All right, its molar mass is 40. So we have 40 grams for every 1 mole. And our mole ratio of NaOH to Na2SO4. Remember, there's like an imaginary 1 here. So for every 2 moles of NaOH, we have 1 mole of Na2SO4. And then we need to turn that back into grams. So for every 1 mole of Na2SO4, we have a molar mass of 142.05 grams. And when I do my calculations here, I get 7.635. All right, so just to make sure everything canceled correctly, we had 2 sig figs in our original number, so we want to make sure we have 2 here. So I will have 7.6 grams for our first calculation. And now we're going to do it with our H2SO4. So we have 6.2 grams. We first need to turn that into moles. So for every 1 mole of H2SO4, we have a molar mass of 98.09 grams H2SO4. And our mole ratio is going to be, remember there's an imaginary 1 here, it's going to be a 1-to-1 ratio. So for every 1 mole of H2SO4, we have 1 mole of Na2SO4. And then we need to turn that into grams. So for every 1 mole of Na2SO4, we have a molar mass of 142.05. And we get an answer of 8.9785. Just like the previous example, or the previous number, we want 2 sig figs. So I'm going to have an answer of 9.0 grams. Remember that 0 counts because it's after the decimal. So our theoretical yield will be the smaller number, which is 7.6. Theoretical. So even though we can make more with our H2SO4, we're limited by the NaOH. So our limiting reactant will be the NaOH. And our excess reactant will be the H2SO4. All right, and those are limiting and excess reactants.